currently coming from San Diego, California, in the United States, and I wanted to focus my project from CS50 on some research that I'm trying to pursue currently on the side. I'm an undergraduate student at Scripps Institution of Oceanography, and I'm studying oceanic and atmospheric science. And right now, I'm trying to pursue my own research pertaining to machine learning algorithms and prediction of sea ice motion in the Southern Ocean. There's recently a paper that focused on the efficiency of machine learning algorithms in predicting sea ice motion in the Arctic. But what we're going to do is try to reproduce that paper in the Southern Ocean to try to see how different properties of the sea ice in the Southern Ocean might make that model behave differently. And this will get us a better idea of how these models will behave moving into the future when sea ice properties are changing via climate change. And it can also give us an idea of how those properties might change over time through different models and forecasting, which will be really interesting. But before we get even started with that, I'm brand new to programming, and I wanted to try to bridge the gap between what I'm learning in this class and what I'm going to be doing in the future with data analysis in Python. And so I just sort of wanted to get a rough start here, learning how the program works, learning some of these third-party libraries up here. Learning how to get the data even into the program was a huge learning curve, and just working with VS Code on my desktop was a huge learning curve as well. And so before I start working with machine learning algorithms, I just needed to make some simple plots just to get used to working with this data. So what I did is I took a netcdf file from the National Snow and Ice Data Center for sea ice motion in 2022, and that's over a time series with each time step being 1 day with U and V along X and along Y gridded ice motion. So from those variables, I was able to make some plots. I was able to plot the total along X and along Y velocity components for the Southern Ocean as a whole. So you can see here we have some plots all the way up to almost 13 centimeters per second in some areas. And then this paper is going to focus on the Weddell Sea. So what I did is I just kind of brute force zoomed in and cropped out the area right here in the Weddell Sea, and then made some plots of this cropped in area. So you can see here we have a pretty strong zero crossing and some directional velocity components here. You can see that we have a pretty negative along X sea ice velocity, as well as a positive along X sea ice velocity. So moving forward with these plots, we can really get some interesting representations of the sea ice motion, and that will help me a lot as I move into working more with this data moving forward in the future.